I'm going to solve this final exam from 2018. Here it is. Let's look at the first problem. So the first problem starts out with a list the conditions a matrix has to satisfy to be in reduced row echelon form. And then it asks me to group some matrices together according to row equivalence. So let's do the first part. So a matrix is in reduced row echelon form if, well, what are the conditions? First of all, every 0 row is below every non-zero row. Secondly, the first non-zero entry of a row is to the right of the first non-zero entry of every row above. Right, that's the echelon form shape. So far, these are the conditions for the matrix to be in row echelon form, and then reduced row echelon form in addition requires that the first non-zero entry of every row is equal to 1, and above these first non-zero entry of every row, the entries are equal to 0. Of course, this was a final exam that was sat in class where it made sense to ask this kind of question. So, of course, on your final exam, I will not ask this kind of question because this exam will be open book and it would be boring. You would just copy this. So, anyway, but this is just a review. So, for part B of this problem, there is a list of matrices that we have to classify according to row equivalence. Right? Row equivalence being an equivalence relation. So we have to, we have to decide which of these matrices are in the same equivalence class, in other words. But the theorem about row equivalence was that two matrices are row equivalent if and only if their reduced row echelon forms are equal. So what we have to do to solve this problem is to compute all the reduced row echelon forms of these matrices. So let's start with A, 2, 0, 4, 1, 1, 3, 2, minus 1, 3. So this matrix is row equivalent to, well, let's swap up this second row rather than dividing by, well, maybe I should have divided by 2. I don't know. Well, too late now. So, first row stays. 2 minus 2 times 1 is 0. 0 minus 2 times 1 is minus 2. 4 minus 2 times 3 is 4 minus 6 is negative 2. 2 minus 2 is 0. Minus 1 minus 2 is negative 3. 3 minus 6 is negative 3. this is equivalent to 1, 1, 3, 0, 1, 1, and then the last row goes away. We've got the echelon thing going, so we're already in row echelon form. We still have to get rid of that 1 there, so we do that by adding this, so subtracting the second row from the first. So 1 minus 0 is 0, 3 minus 1 is 2. Now it's in reduced row echelon form. Right, just to point out, I'm writing equivalence signs here because these matrices are not equal, they're just row equivalent. So let's do the same thing for B. 1, 2, 5, 1, 0, 1, 2, minus 1, 0. Okay, so let's do minus the first and minus twice the first. 1, 2, 5, 1 minus 1 is 0, 0 minus 2 is minus 2, 1 minus 5 is negative 4, 2 minus 2 is 0, minus 1 minus 4 is negative 5, and 0 minus 2 times 5 is negative 10. Okay, so this is equivalent to 1, 2, 5, 0, 1, 2, and this is also 0, 1, 2, so this goes away. And then we have to get rid of this 2 there, so by subtracting twice the second row from the first, so 1, 2 minus 2 is 0, 5 minus 2 times 2 is 5 minus 4 is 1. This is the reduced row echelon form. So we see that the reduced row echelon form for A and B are different, so there's no way that A and B are row equivalent already. Well, we have to do this for C and D also. So C is 1, 1, 3, 1, minus 1, 1, minus 1, 1, minus 1. So this is equivalent to 1, 1, 3. So let's subtract the first row from the second. 1 minus 1 is 0. Minus 1 minus 1 is minus 2. 1 minus 3 is minus 2. And add the first to the last is 0, 2, 2, excuse me. 1, 1, 3, 0, 1, 1, 0, 0, 0. We have to get rid of that 1 there by subtracting the second row from the first. 1, 0, 2, 0, 1, 1, 0, 0, 0. And the last one is D. One minus 1 minus 1, 1, 1, 3, minus 1, 1, 1. So this is row equivalent to, so let's subtract the first from the second. 1 minus 1 is 0. 1 minus minus 1 is 1, plus 1 is 2, 3 plus 1 is 4, add the first to the last, 0, 0, 0, make the pivot equal to 1, get rid of the minus 1, by adding the second row to the first. 0, 2 minus 1 is 1, 0, 1, 2, 0, 0, 0. So we see that there's exactly two reduced row echelon forms. So we have that A is row equivalent to C, because they're both row equivalent to 1 0 2 0 1 1 0 0 0, and B is equivalent to D because they're both equivalent to this matrix B and D. So A is equivalent to C and B is equivalent to D, but but there's no further equivalences between them. So yeah. So A is equivalent to C, B is equivalent to D, but A and C not row equivalent to B and D. So that problem is now finished.